Hey guys, welcome to the Chapter 9 review. We're going to start by looking at the Chapter 9 graphing review. The first thing I want to remind us of is that this is a worksheet that we're not using our graphing calculator on, and that's because on the test you will not be allowed to use your graphing calculator. Whenever I have a rational function, we worked with only two simple types. This is the first type, and what makes this different than the second type we'll see is that in the numerator, I do not have an x value, I only have a constant. So the first thing I want to do is find the two asymptotes. So in order to find the vertical asymptote, I'm setting my denominator equal to 0, so I get x equals -3. So that is going to be our vertical asymptote. And what that means for us, for the domain, it is all real numbers except we know x cannot equal -3. Now to find the range, what I'm going to do is I'm going to take this number right here, that constant that's not a part of the fraction, and I'm going to say y equals -1. So our range would be all real numbers except y equal to -1. So the next thing we're going to go ahead and do is pick the ordered pairs that we're going to graph. And in order to do that, I need to choose some x values. And I went ahead and I already chose two x values that are to the left of our vertical asymptote. I'm sorry, these would be the ones to the right, and these would be the ones to the left. So my x values really will vary based on what our asymptote is. The way we're going to go about and do this, I'm just substituting this number in for x. So you can see I've already written -2 over -2 plus 3 minus 1. I end up getting -3 as an answer, and that means that we actually have an ordered pair here of -2, -3. I'm going to go ahead and substitute in the three other x values and just write down what the y values are. I think you guys will probably be pretty good on doing that on your own. Okay, so I went ahead and filled in that chart there, and that's giving us 4 different ordered pairs. So now I'm going to go ahead and move over to my graph, and I'm going to start by graphing our two asymptotes. So I went ahead and I sketched our two asymptotes. Just a reminder that when we are finding the asymptote, it's very important that we are writing it as x equals or as y equals, not just giving a number, because it is an equation of a line. Remember, they're dashed because it's not a part of the function. I also graphed the ordered pairs, and we learned in class that's enough really for us to understand what this hyperbola is going to look like. I know it's curved, it's getting close to the asymptotes, but not actually touching them. Okay, what makes this problem a little bit different is this time I have that binomial in the numerator. The only thing that changes is the way that we find our two asymptotes. So in order to find the vertical asymptote, I'm still setting the denominator equal to 0. I'm going to do it down here. -4x minus 5 equals 0. So I end up getting x equals -5/4. So I'm going to go ahead and write that, making sure I'm writing x equals. Our domain is all real numbers except x equals -5/4. So that really is the same. What changes this time is to find the horizontal asymptote. I'm doing y equals a over c, which are these two numbers over each other. So I'm really looking at the coefficients. So in this case, I would write y equals 3 over 4 because the negatives cancel out. Our range all real numbers except y equals 3/4. So I'm choosing 4 different ordered pairs. Once again, 2 of my x values are going to be to the right, 2 of them are to the left. And if you wanted to choose -1, that's fine. It doesn't matter. So I went ahead and substituted in those ordered pairs, and I sketched what they would look like on the graph, and I can see once again that this is forming a hyperbola that kind of looks like it's in quadrants 2 and 4, so it's here and here. We also talked about the fact that if it's not here and here, it's going to be in quadrant 1 and quadrant 3. So on the test, there will be one problem where you are graphing like 1 and 2. And then I would expect at least 2 problems like this section where all we're going to do is find the horizontal asymptote and the vertical asymptote. Number 3 shows the basic one where for our horizontal asymptote, I'm just setting this number equal to y. So I'm going to say y equals -2. For our vertical asymptote, remember I'm always setting our denominator equal to 0. So in this case, I think we can do that in our heads, and I get x equals -3. Our next problem, okay, this time when I set this equal to 0, I get 3x equals 4. So our vertical asymptote is x equals 4/3. Our horizontal asymptote, this time I'm taking those coefficients of the x's. So I'm going to write our HA is y equals 2/3. It honestly does not get any tougher than that. It really is memorization and just knowing what to do. So for number 5, -5x plus 2 equals 0. So I have -5x equals -2. So our vertical asymptote is x equals 2/5. Our horizontal asymptote is y equals, I'm setting those coefficients over each other, so I get -2/5. Lastly, I'm going to do -2x minus 1 equals 0. -2x is 1. So x is, sorry, that's an equals there, -1/2. So that would be our vertical asymptote. For a horizontal asymptote, I know it's y equals, and I'm setting those coefficients equal to each other. So, I'm sorry, not equal to each other. I'm doing a over c there. So I end up getting the horizontal asymptote is y equals 1/2. So this will be like the first section of the test. If you feel good on these, you'll be great on the problems I'm going to ask you on the test. So now we're moving on to the main portion of the test. And there really are 3 different types of problems. We have our simplifying, which involved expressions like number 1, multiplication like number 2, or some division. So that's our first type of problem. Our second type was when we were adding or subtracting, and our complex fractions kind of add into that section as well. Our final one is when I have an equal sign, and that's when I know I'm actually solving. So whenever we're simplifying, so this first section, I'm going to begin by factoring. So when I factor this, I end up getting x plus 5, x plus 3 over x plus 5, x minus 5. If you are struggling on factoring, that is something I definitely would spend time on because that will kill you on this test. My x plus 5's cancel each other out. So I have x plus 3 over x minus 5. We've talked about this a lot in class, but I cannot cancel out these x's because they are binomials. So that would be my final answer. There definitely will be problems this basic on our test. Looking ahead at problem number 2, this one's slightly different because we have monomials. I can either just multiply straight across, or I'm going to cancel out the numbers just because I don't want to multiply that big of number. So I know 5 goes into 15 3 times, 3 goes into 12 4 times. So when I multiply straight across, I get 7xy squared over 4y. The only thing I can reduce here are our y's. So remember, I'm battling. I'm looking to see who has the highest exponent. Our numerator wins by 1, so it's 7xy over 4. Number 3 is more factoring, so I have x minus 3x plus 1 over x plus 1, x minus 1. I can go ahead and cancel out my like terms. So x minus 3 over x minus 1 is our final answer. Number 4 looks a little bit tougher because now we do have to deal with some multiplication. So I started by factoring all of these, and now I can just look and see if we have anything that is the same that can cancel out. So I'm canceling out our x minus 2's and our x plus 2's. So I'm left with x times x plus 2 over x minus 5. That is all I can do. This would be our final answer. I do not need to go ahead and multiply it out. In fact, it makes my life easier if you don't. It also makes your life easier because that is less work that you actually have to do. Looking ahead at number 5, once again, just a basic expression. So I went ahead and factored it. My n minus 4's cancel out, so I have n plus 6 over n minus 7. I would definitely expect us to do pretty well on those types of problems that are pretty basic. It's really just checking, can we factor, and do we understand what we can cancel out? Okay, number 6, this is the first time I am dealing with this division sign. We know all division means is multiplying by the reciprocal. So I'm going to write this as x squared y to the 4th over 8x cubed y cubed times, and I'm going to do two things at once here. I'm going to make this 16x squared y cubed, there we go, over x squared y to the 4th. So I went ahead and I distributed that squared, and then I also changed it into a multiplication problem. Now I can look and see if anything is going to cancel out, specifically our numbers, and I know that 8 goes into 16 two times. So I end up getting 2x to the 4th, y to the 7th, over x to the 5th, y to the 7th. Looking at these, the y's would cancel. When I battle, my x's, the denominator would win by 1. So I'm left with 2 over x. Number 7, what can be a little bit tough is that we have 3 different terms here, but I'm only dividing by this last one. So that is the only one whose fraction I went ahead and flipped. So now looking at this, I'm going to reduce the 3 and the 6. So I have 2x to the 4th, y to the, 3, 4, 5, 8. Remember, when I'm multiplying things that have the same base, I'm adding their exponents. So 4th, 3rd squared, I get 7, 9. Y to the 5th. When I battle these with the x's, my denominator wins by 5. With the y's, my numerator wins by 3. Okay, number 8, this looks more similar to the type of problem that we had on our quiz. Honestly, the last 2 classes. So I'm starting by trying to factor this, and we might kind of run into a problem here because this, I might start to do a 3 and then I realize, oh, I actually cannot factor that. So it doesn't work. I'm going to have to go ahead and erase that. So it just stays x squared plus 2x plus 3. Okay, here I have x plus 3, x minus 2 over 4x. Looking at this, my 4x's cancel out, and that is about it. So I have 1 minus x times x plus 3 times x minus 2 over x squared plus 2x plus 3. This entire thing then would be our answer. There's nothing more we can do because we can't factor that denominator. Now if it said minus 3, then there would be some stuff that we could do with that. The one thing that I want to point out is this 1 minus x. And a lot of you struggled with this on our first quiz of this chapter. If I could eventually factor the denominator so I had an x minus 1, remember we called these opposites. So in order to make them the same, I would need to factor out a negative 1. And I'm sure we will run into that in problems later on in this review. So moving on to the next page, I definitely want to focus on this. I would almost guarantee 100% we will have to factor like this on our actual test. So remember, this is when we figure out what cubed makes 64x cubed, and it's 4x, and what cubed makes 1, which is 1. So when I factor it, it goes 4x, 1, 4x squared, which is 16x squared. 4x times 1 is 4x. 1 squared is 1. The way that we figured out our signs, we use that word SOAP, so same, opposite, always positive. And something kind of amazing happens here. I'm not even going to rewrite this out because I can just see that this and this are going to cancel out. So our final answer would be x minus 3 over 4x minus 1. And not that this will always happen, but if you guys have a problem like this, use this to help you out because chances are, most of the time, this is going to be the same as something that is in the denominator. Number 10, I went ahead and factored. Since we had division, I had to flip this, and I factored it. I was running out of room, so I just wrote those both, but know that they would be right next to each other. I can look and see what cancels out. The x plus 3's cancel, the 4x plus 1's cancel, so I'm left with x over 4x minus 1. The other thing I want to point out here is that when I have something like this that doesn't look like it's a fraction, it can be a good idea if we put it over 1 to remind us what we could actually cancel it with. Number 11 starts up that new type of problem where we are actually adding and subtracting fractions here. First thing I need to figure out is what is our LCD? This one was really easy because they are exactly the same. So that means that I can just combine my numerators. X plus 3x is 4x. Negative 7 plus 7 is 0 over negative 8x because that is our denominator. Since I have two monomials here, I can just reduce this. The x's cancel out, and I end up with negative 1/2 as our answer. Number 12 is probably a better look at the types of questions you guys will have. So in order to figure out the LCD, the first thing I did was factor. And we spent a lot of time in class on this. I know our only two factors in our LCD are x plus 5, x minus 5. And if I look, neither of those have an exponent higher than 1. So that would just be my LCD. And on the test, you guys, definitely write that down. That's telling me when I'm grading it that you are on the right track. It's also helping you out in knowing exactly what to do. If I were you, I would also right away kind of write which problems you need to find an LCD on. So just a reminder, ones I need to find an LCD on. Adding and subtracting, also when we're solving. So now I'm going to look and see, what are we missing in this denominator that we have in the LCD? And in this case, it's actually nothing. I have everything I need. So I'm going to go ahead and write this out. The second one, if I look at x plus 5, what are we missing? And we're missing an x minus 5. So I'm multiplying the top and bottom by x minus 5. The common thing I see people want to do now is go, oh, those are the same, let's cancel them out. The reason why we cannot do that is because I have this negative sign in between. This is not just in terms of multiplication. So I need to go ahead and multiply those things out then and add my like terms together. Our denominator is just in terms of multiplication, so it's okay. Now, the second most common mistake I see is people forgetting to distribute a negative along with that too. When I distribute that, this is what I end up getting in my numerator. Now I can just add those like terms together. When I add them together, I notice something kind of strange happens. And I've kind of been telling you guys throughout notes, if you can factor it to make sure nothing cancels out. This case, those are exactly the same. They cancel out. So our final answer would be 1 over x minus 5. So make sure we are simplifying as much as we can. If that said x plus 6 or x plus 10 or anything like that, then this would have been our final answer. Since I have two binomials that are exactly the same, I can cancel them out. Okay, number 13, I started by factoring, and the first fraction is actually the only one I can factor. So our LCD is x plus 3, x minus 3. That first one, I'm not missing anything, so I'm just going to write 4x over x plus 3, x minus 3. The second one, I am missing an x minus 3, so I need to multiply by x minus 3 over x minus 3. The last one, I am missing an x plus 3. So I'm multiplying the top and bottom by x plus 3. So I have minus 2 times x plus 3. At this point, can I cancel stuff out? And you guys should all be saying no. And the reason is I have a plus, I have a minus. It's not in terms of multiplication. Yes, I have a plus and a minus down here, but notice that these two factors are multiplied, so it is okay. So when I distribute the 2 and the -2, that's what our numerator ends up being. I'm going to add our like terms together now, so I end up getting 4x minus 12 over x plus 3, x minus 3. Once again, I always need to check, can I factor this further? And this time I can, and I'm going to go ahead and change colors here. I can take a 4 out, and it would become 4 times x minus 3 over x plus 3, x minus 3. Those x minus 3's cancel out, so our answer is 4 over x plus 3. So I cannot stress to us enough how important it is to make sure we can factor as much as we can, simplify our answer as much as possible. Looking at number 14, I started off by factoring. In order to find our LCD, and I'm just going to write it up here, I know we only have two factors, x plus 3 and x minus 3. The thing that makes this one a little bit different is one of them has an exponent higher than 1. So that means in my LCD, I need to have a squared up there as well. And it's kind of tough to see, but that's okay. So when I look at that first fraction, I need to ask myself, what am I missing in the denominator? And we are missing an x minus 3. So I'm going to multiply by x minus 3 over x minus 3. So I'm going to go ahead and write that out. The second one, I am missing an x plus 3. So I have minus x plus 3. At this point, I cannot cancel stuff out because of this minus sign. So I'm going to have to FOIL and distribute the negative. So this is what I end up getting in my numerator. Now I can add my like terms, and I get x squared minus 3x minus 6 over x plus 3 squared, x minus 3. I cannot factor that any further, so that would be our final answer. Looking at number 15, I think this can be a really tough one for us. So I went ahead and I broke this down into our prime factorization, and I went ahead and just rewrote all the factors that we are multiplying. Now the only other thing I need to do is look and see if I have any exponents higher than 1. And I can see for x, I have a squared, and for 2, I have a squared. So I'm going to have to go ahead and write those. So I end up getting 12x squared times x minus 3 as our LCD. So looking at this, in this first fraction, in the denominator, I'm missing a 2, because I have 6, I need it to be 12, and I'm missing an x minus 3. So I end up getting 10 times x minus 3 over, I'm just going to write this as 12x squared times x minus 3. My second one, I'm just missing a 3x. So 3x times x is 3x squared. So when I distribute and add our stuff together, I get 3x squared plus 10x minus 30. Sorry, I'm running out of room there. Over 12x squared times x minus 3. Some of you guys might notice, oh, I have a GCF, and if we really wanted to, okay, let's just see what happens. If I take 3 out, I'm left with x. Oh, just kidding, I don't have a GCF. I don't know what I was thinking there. The reason why I don't have a GCF is because I can't take 3 out of this term. So that means this is our final answer. Okay, and we finally have come to the last one on this page, and I think problems like this confuse us because we look at all those denominators and I can't factor any of them, so that means our LCD is them all multiplied together. If you guys have noticed, the last few problems we've been going through are very, very similar. It really is understanding the basic concept, and I would definitely practice what we did on the quiz that you guys got handed back to you in class. I think those have some good, like tough examples on them. And that would just be a good thing for you guys to practice. So my first one, I noticed that I was missing an x and a 2x minus 3. So I went ahead and multiplied, and I end up getting 4x squared times 2x minus 3. My second one, I'm missing an x and an x plus 1. So that's where this comes from. And that third one, that minus 4 over x, I'm missing an x plus 1 times a 2x minus 3. Once again, I can't just cancel stuff out because of the plus and the minus. I need to multiply. So once I multiply that whole thing together, and I went ahead and I FOILed those over here, and I distributed -4, and that's where this comes from. I'm sorry, that should be, let me make that, sorry, that's a plus 12. And I know it's over this whole denominator. To save some time, I'm just going to write that in our final answer. But I would not suggest that for those of you that messed up on that on your quiz. So now I'm just going to add my like terms together. So I have 8x cubed. Let's see, I have minus 15x squared plus x plus 12 over x times x plus 1 times 2x minus 3. And that would be our final answer. The only thing we really didn't do much on this that I would expect you guys to know how to do is dealing with opposites, and I know we talked about that a lot in class. Now everyone's favorite, complex fractions. I'm going to show you guys the second method I talked about using in our notes, and that's multiplying by the overall LCD. And what that means is I'm looking at all 4 of these and figuring out what is the LCD, and it ends up being 12x. So I'm going to multiply everything by 12x over 1. The reason why I can do this is because I'm really multiplying by 12x over 12x because I'm dealing with the numerator and the denominator. That's like multiplying by 1. So I end up getting 48x over x plus 36x over 2x over 12x over 3x minus 36x over 4x. At this point, tons of stuff cancels. So I have 48 plus 18 over 4 minus 9. So when I add those, I get, let's see, 6. I end up getting negative 66 over 5. That would be our final answer. I cannot simplify that any further. I'm pretty sure we actually did 18 in our homework. I started off by factoring all 3 of these. Our overall LCD ended up being 2 times x plus 1 times x minus 3 times x minus 1. So I'm actually going to cancel some stuff out in my head. When I distribute to this first term, the 2's cancel. The x plus 1's cancel. The x minus 1's cancel. So I'm left with x minus 3. In the denominator, this one, the x plus 1's cancel. So I have 4 times x minus 3, x minus 1. When I distribute to the final one, the x minus 3's and the x plus 1's cancel. So I'm left with 2x times x minus 1. I cannot leave this as my answer because I have this addition, so I need to go ahead and FOIL this out and add like terms. So when I go ahead and multiply that out, that's what I end up getting in my denominator. And now I just need to add my like terms together. And I'll do this in a separate color just so it's easy to see. Okay, so I have x minus 3 in my numerator. My denominator, I have 6x squared minus 18x plus 12. That I can factor further. I can take a 6 out. It actually doesn't help me simplify the problem at all though, so I can just leave that as my final answer. If I wanted to take more out, I could. I would expect to see a few of these on the test. Remember, find the overall LCD, multiply everything by the LCD, and then you are in pretty good shape just to go ahead and simplify it. Final type of problem, solve and check. Remember, checking was because I didn't want to have extraneous solutions. So first thing I'm doing is finding our LCD. In this case, it is 30x. So I'm going to do distribute this and cancel at the same time. So I end up getting x squared minus 6 equals 5x. So I'm going to go ahead and get everything over on the same side. I'm going to factor this. So I'm going to do x minus 6, x plus 1. Remember, check with inside outside and it works. I'm going to set these both equal to 0 now, so I get x equals 6 and x equals negative 1. Now, I need to double check them, and by checking it, I mean plug this into the denominators. If it makes just one of the denominators equal to 0, it doesn't work. In this case, neither of them make the denominator 0, so we do have two different solutions. Okay, number 20, I factored that x squared minus 4, and I found that the LCD is x plus 2, x minus 2, so I'm going to go ahead and distribute. So I have 2x times x plus 2 equals 1, because everything cancels out, plus, I'm just going to write this x squared minus 4, because that is x plus 2 times x minus 2. Now I'm going to go ahead and do my work here. 2x squared plus 4x equals x squared minus 3. I'm going to get everything on the same side. So x squared plus 4x plus 3 equals 0. So I have x plus 3 times x plus 1 equals 0. When I set those equal, I get x equals negative 3, x equals negative 1. I need to check both of those and make sure that they do not make our denominator 0. They do not. So those would be our two different answers. 21, we had two options. I can cross multiply if I want, or I can find an LCD. It does not matter. I'll go ahead and cross multiply on this one just to show us what I'm talking about. So I'm doing 5 times x squared minus 9, 2x times x minus 3. So I have 5x squared minus 45 equals 2x squared minus 6x. I need to get everything on the same side, so I get 3x squared plus 6x minus 45 equals 0. I can factor out a 3, so I have x squared plus 2x minus 15. So this becomes x plus 5, x minus 3 equals 0. When I set those equal to 0, the 3 equals 0, I really don't care about that. When I set x plus 5 equal to 0, I get x equals negative 5. When I set x minus 3 equal to 0, I get x equals 3. When I plug these back in, negative 5 works. 3 makes this denominator equal to 0. It actually makes that one equal to 0 as well. But remember, if it only makes one of them equal to 0, that's enough for us to know it's extraneous. You would need to make it really obvious to me on the test that you know x equals negative 5 is the only solution. Number 22, our LCD is x minus 4 because that is our only denominator. So when I distribute, I get 2x equals 8 plus 3 times x minus 4. So 2x equals 8 plus 3x minus 12. Make sure you guys are taking your time on the basic multiplying and adding. I know you guys know how to do all of that. So I get 2x equals 3x minus 4, negative x equals negative 4, so x equals 4. The only problem is when I plug this back in, 4 minus 4 gives us 0. That means it's extraneous. But remember, extraneous solution is not our answer. Our answer is no solution. That means nothing works. Okay, number 23. When I factor, I find that my LCD here is x plus 1, x minus 1. So I'm going to distribute. I have 3x times x minus 1 equals 12. And then when I distribute to the 2, I have 2. And I'm going to FOIL those in my head and get x squared minus 1. So I have 3x squared minus 3x equals 12 plus 2x squared minus 2. I'm getting everything on the same side, so I have x squared minus 3x minus 10 equals 0. So I'm going to do x minus 5, x plus 2. So when I set those both equal to 0, I get x equals 5 and x equals negative 2. I need to double check, do they make my denominator 0? Neither of them do, so they are both solutions to that problem. 24 can be a little bit tricky, and I'm actually, I don't know why I'm rewriting it there. Let's undo that. Oh, that's a little crazy. Hang on. There we go. I'm going to start by cross multiplying here. So I have negative x squared plus 27 equals x squared minus 7x plus 12. I want to get it set equal to 0, so I have 2x squared minus 7x minus 15. So when I factor this, I know I need to do 2x and x. So I'm going to do a negative 5 and a positive 3. So I'm going to do plus 3 minus 5. When I set these equal to 0, I get x equals negative 3 halves, x equals 5. If I double check, they both make our denominator something other than 0, so they both work. And we are finally here, the final question on the review. And we had some, I forget if it was last time or the time before, that were like this. And it really is making us solve two problems in the same number. And then we're going to choose which of these options is true. So I'm going to start with column A by cross multiplying. So when I cross multiply, you can kind of follow my work here. I get x equals negative 3. When I plug that back in, it makes our denominator negative 2, which is okay. So now I'm going to go ahead and look at our second problem. Our second problem is a little bit tougher. I'm going to multiply by the LCD, which is 12x. So when I distribute that to all three of those, I get 60 minus 32x equals 1. So I have negative 32x equals negative 59. So I'm going to divide both sides by negative 32. At this point, I honestly don't really care what this solution is because I know these negatives cancel out, which make it positive. So that means that the quantity in column B is going to be bigger. Okay, so some things I just want us to focus on. We've spent a lot of time going through these different types of problems. Continue to practice. Use your quizzes as a guide. The thing I'm talking about with opposites, remember if I have something like, let me make that a little bit different. If I had x minus 1 and 1 minus x, okay, that would be x minus 1 over negative x minus 1. So my answer would be negative 1. A lot of us are forgetting that negative, so make sure we remember that. I am going to go through problems at the very beginning of class. So if you have any last minute stuff, that would be a great time to ask. And don't forget to do your responsive writings. Okay, have a great rest of your night. I will see you in class.